Graphing Rational Functions Summative Review. For the first objective, you will need to identify asymptotes, holes, and intercepts of rational functions and sketch the graph of a rational function. When something doesn't exist, such as an asymptote or a hole, you will need to write none in the blank. That way I know that you know there are none, not you have no idea what to do. Okay, so don't leave something blank. You need to indicate none. Now, as we go through these, you will notice that I've got all the answers here. I'm just going to explain them. First thing you want to do is simplify. Can't simplify this function. Next, you want to identify any values that would cause the denominator to be 0. In other words, restricted values. So you're going to say that x squared, because that's the denominator, does not equal 0. Well, that just means x does not equal 0. So, boom, there's your vertical asymptote. X equals 0. Put your dashed line there. Now, notice that I can't cancel anything. This x squared does not cancel with this x squared. So we're good there. That means there's no holes. Nothing cancels. Horizontal asymptote. I'm going to do y equals the lead coefficient over lead coefficient as long as they are the same. So 5x squared over 1x squared. In this case, my x squareds go away, and it leaves me with just 5, or y equals 5. That's my horizontal asymptote. If you have a horizontal asymptote, you can't have a slant. The x-intercepts, you're going to set y equal to 0 and solve for x. So here you're going to do 0 equals, and really as long as the numerator is 0, it doesn't matter because 0 divided by anything is 0. So I just set 0 is equal to 5x squared minus 3, and then I solve for x, so I get 3/5 is equal to x squared, and here I would plug this into the calculator, and you would get plus or minus 0.77 repeating, and that's where you can approximate those points on your graph. You would then have the red asymptotes and the 2 blue dots. At this point, you also have to check the y-intercept. The y-intercept occurs when x is 0. Well, I can't make x 0 because it's restricted, so therefore there's no y-intercept. So now at this point, I would take a look at the calculator, and I would either graph on the calculator or I would plug in numbers like 1 and 2 and -1 and -2 and see where the points are, and just even approximating those points so that you get an idea of how the graph is behaving. If I plotted these points, and I know the asymptotes are something that the curve will approach, then I would know these black curves would be the graph. Okay, great. Let's move on to the next one. Our next line is x squared minus 4 over x cubed plus 2x. First thing to do, simplify. So you're going to get x plus 2 times x minus 2 because the numerator is a difference of squares. And then in the denominator, it's a greatest common factor, so you're going to take the x squared out and leaves you with x plus 2. Now, you can notice that the x plus 2's will cancel. So now you've simplified this expression so that it's x minus 2 over x squared. Vertical asymptote, well, remember you have to take, before you cancel it, you say that x cannot equal 0 because 0 would cause it to be undefined, and x can also not equal -2. So I put a -2 in here, this factor is 0. Now, the vertical asymptote occurs any place that was not canceled out. So that's my x equals 0. The hole occurs any place where something is canceled out. Since the -2 got canceled out here, I know I've got a hole at -2 comma something. To figure out what that something is, I'm going to do y equals -2 minus 2 all over the quantity -2 squared. Essentially, I'm going to plug the -2 in for the x's, and I wind up with -1, -4 over 4, or -1. And so I draw my hole. I now know that this curve is going to be down here. I don't know about this guy yet. Now, horizontal asymptotes. When I look at this, I don't have any x cubes. So I'm going to do y equals 0 x cubed. Remember, I have to have them so they've got the same degree over 1 x cubed. 0 divided by anything is 0, and so y equals 0 is my horizontal asymptote. If I have a horizontal asymptote, I won't have a slant. X-intercepts. Well, y can't equal 0 because that's a vertical asymptote. And then, oops, sorry, x can't equal 0 because that's a horizontal asymptote. Y equals 0 turned out to be a horizontal asymptote. So therefore, I don't have any x-intercepts or any y-intercepts. This curve here is coming up. Well, actually, I take that back. I do have a y-intercept or an x-intercept. I don't know what's wrong with this key here. So this would be 0 is equal to x squared minus 4 and x. So 4 is equal to x squared. X could be equal to, now here's where we got to be careful, is the plus or minus 2. Now remember, minus 2 is restricted. So that's a no-no, but the plus 2 is not. So I'm actually going to cross at 2. But remember, we said we can cross horizontal asymptotes, but what happens is it comes right back and it rides really close to, just above instead of below the asymptote. Okay, so the x-intercept is at 2, 0. Oops, terrible 0, but there we go. Just color that in. Okay? Number 3. We've got to factor this. We've got to factor the numerator and the denominator. And so we shall. In the numerator, we've got a greatest common factor of 2. It's going to leave us with x squared minus x minus 6 all over 4x x squared minus x minus 6. Well, how convenient. This cancels with that. But before I just cancel it out, I do need to factor it. So I've got 2, and I've got this whole thing up here, right? And when I factor it, I know factors of -6 that will add to -1 are -3 and +2. So in the denominator, I'm going to get 4x x minus 3 and x plus 2. All right, so now I know that x, my restricted values, cannot equal 0, 3, or -2. And then I come along and I know that the x minus 3's cancel and the x plus 2's cancel. So therefore, at 3, I have a hole, and at 2, I have a hole, and at 0, I'm going to have a vertical asymptote. So y equals 0 is my vertical asymptote. My holes at -2 and 3, I'm going to have 2 over 4, or this simplified up here to 1 over 2x. So when I put in a -2, I'm going to get -1/4 or -0.25. So it's, whoops, it's right here. And then when I put a 3 in, it's going to be 1/6, 3 and 1/6. So it's again right here, just very close. Since I have my horizontal, I've got a squared and a cubed. I don't have any cubes up here, so it's going to be 0x cubed. 0/4 gives me y = 0 is horizontal, therefore no slant. My x-intercepts, let me get rid of some of that there. My x-intercepts, if I go back here, that means that y is equal to 0. So I set 0 equal to x minus 3 and x plus 2. I also have the 2 here. Okay, divide everything by 2, so boom, that goes away. But x can't be 3 and x can't be -2 because those are restricted. Therefore, there are no x-intercepts. A y-intercept, x can't equal 0, so I don't have a y-intercept. So we've taken care of all of that. Okay? The only two places where y could equal 0, x is restricted. Then again, you can pull up your calculator, and we'll do it with just one of these. Okay? If I pull up this guy, I can come in here, and I can do 2x squared minus 2x minus 12, put a parenthesis, divided by 4x cubed minus 4x squared minus 24x, in the parenthesis, hit enter. And then I'm just going to do a zoom standard, and I'll look at the graph. Okay, so here I can tell, remember the pixels get to the point where I can't get it any closer. So I've got a curve here and a curve here. Notice that I don't see the holes. Now, if I go to my table, I can see that there's an error at 0, there's an error at 3. And if I move up, I'll notice there's an error at -2. Remember, there's a hole, a vertical asymptote, and a hole. But the graph itself is not going to show any of that. You can kind of tell that there's asymptotes, but you can't tell exactly where the holes are because the pixels are just bigger than a dot, than a point. Okay? So when I look at this, I know how to graph my curve. Questions? Make sure you bring them to me. Moving on to number 4. Here, we've got 2x squared plus 4 over x plus 1. Let's see here. Let's just be a little more creative. Now, if I'm going to factor, I'm going to do 2 over x squared plus 2. And then I have x plus 1. Nothing cancels. X cannot equal -1. That didn't cancel out. So I've got my vertical asymptote. Since nothing canceled, there's no holes. A horizontal asymptote. I have 2x squared. So if I do 2x squared over 0x squareds, notice I can't divide by 0, so there's no horizontal asymptote. That being the case, I now have to think about having a slant asymptote. And in fact, I do have a slant asymptote. Now this is where, if you are in regular algebra 2, you just say that there is no horizontal asymptote. If you're in algebra 2 trig, or in future years in advanced algebra, you're going to figure out a slant asymptote. To do that, you're going to do the long division. So you're going to divide 2x squared plus 0x plus 4 by x plus 1. X will go into 2x squared, 2x times. Multiply 2x squared plus 2x. And then you are going to subtract everything. So conveniently, the 2x squared minus 2x squared goes away. 0 minus 2x leaves you with negative 2x plus 4. X will go into negative 2x minus 2 times, and we don't care about the remainder. So y equals 2x minus 2, right here. That is your slant asymptote. So what do? Well, we draw our slant asymptote in. Right along this line, we put a point at negative 2 and a slope of 2, so we go up 2. Oops. We go up 2 to the right 1. Sorry, the y-axis is on 2s and the x-axis is on 1s. And that's because of the size of this guy. The x-intercepts, that's when y equals 0. So when y equals 0, notice that that can't happen. That does not happen. Let's see here. Because at negative 1, okay, I can't get anything to work out there. Sorry. And notice there's nothing. The black curves are here and here. They're not touching the x-axis. They are crossing the y-axis at 4. If I put in 4, okay, if I put in 0 for x, I get 4 over 1. Boom, I'm right there. That becomes 0, that becomes 0, so you're just left with 4 over 1. All right? Again, slant asymptotes are only for Algebra 2 trig or Advanced Algebra 2. Number 5. Okay, here, and to speed this up a little bit, just because this is the review, and we're doing all the same things, what I'm going to do, I'm going to go back to the regular pen, because this is getting a little bit too crazy. We can do, here we go. So we can look up here, and we're going to get negative 3 out. And we're going to get an x out. And that's going to leave us with x squared minus x plus 2 in the numerator. And in the denominator, we've got x squared minus x minus 2. And if we factor that, we're going to get x minus 2x plus 1. Notice that these two are the same, x squared minus x minus 2, x squared minus x minus 2. I just factored it here. Now, what does that tell us? That x cannot equal 2 or negative 1. Great. That means I've got vertical asymptotes or holes when x is 2. Well, it turns out that they're both vertical asymptotes. I have 2 vertical asymptotes because neither okay. And sorry about that. My phone was going off. Actually, and as my phone was going off, I realized these two are not the same. This is x squared minus x minus 2. This is x squared minus x plus 2. So it doesn't actually cancel. So these are both vertical asymptotes. That since nothing canceled, that means there are no holes. A horizontal asymptote. I have x cubed over x squared. So if I give myself a 0, x cubed in the denominator, and then I set the lead coefficient over lead coefficient, -3 over 0 is undefined, so there's no horizontal asymptote. That would indicate that there might be a slant. There is a slant. How do I know? The degree of the numerator is 1 more than the degree of the denominator. So again, I have to do my division. That gets a little bit crazy doing this with the mouse. So suffice it to say that you would do x squared minus x minus 2, and you would divide that into -3x cubed plus 3x squared minus 6x. X squared would go into -3x cubed, -3x times. I multiply this out and I get -3x times x squared is minus 3x cubed. -3x times -x is plus 3x squared. -3 times -2 is plus 6x. And when you come through and you change all of your signs, that cancels, and that cancels, and this leaves you with -12x, which is actually just the remainder. Remember, we don't care about the remainder, so y equals -3x is our slant asymptote. Okay, now, so I erase that. You can always redo the video. I put a point, okay, I graph a point at 0, and then I go down 3 and over 1, plot my point, and draw my horizontal asymptote. My x-intercepts happen to be 0, 0, and my y-intercept is 0, 0. Okay, I set x equal to 0, and I wind up with 0 over -2. All right. Sorry, I said x equal to 0. Yes, that's 0. That's 0. That's 0. 0 over -2 is just 0. And then I set y equal to 0, and x just happens to be 0 as well. Okay? The only other places that x could be 0 are places where I have my vertical asymptotes. And then you graph this, and you would see the shape like this. Now on this one, the one thing I want to show you, when you graph it on y equals, we're going to clear that. When you graph this, plus 3x squared minus 6x divided by, then there, yes, x squared minus x minus 2. Poop. 3x cubed. Come back down. Plus 3x squared minus 6x divided by x squared minus x minus 2, parenthesis. Hit enter. Now notice that when I graph this, yeah, I'm going to kind of see the center, but I don't see the other two. Why? Notice how far up and how far down they are. But I know I have vertical asymptotes. So while I can see the behavior here, I can't see the other behavior out here. That would indicate that I need to either go wider or higher. So I'm going to go to second window. And I'm going to, oops, not second window, just window. And I want to find out what's happening out here and out here. So therefore, I'm going to make my y minimum something like -30, and then positive is 30. I may or may not see anything. If I don't, I can keep zooming myself out. But notice, now I can see how the graph works. I just had to zoom back. I had to expand my vertical axis. Now this thing gets crazy thick here because when I did window, I left the Y scale as 1. If I wanted to do this better, I could make the Y scale like 5, and then notice it looks a little bit nicer when it's graphing. Okay, but again, if I just graph this here, I have to know where my asymptotes are. You have to be able to answer these questions, not just throw a sketch up there. And your sketch has to be somewhat accurate, somewhat correct. Okay. Finally, number 6. Again, you're going to factor this. Okay. Factor the bottom. Actually, you're going to factor the bottom. The numerator gets a little bit crazy to factor. Okay, it's the 4th degree. It's a big old crazy one. And then you're going to look at your horizontals, slants, X-intercepts, and Y-intercepts. Okay. So now down here in the bottom, you know you've got a greatest common factor up here. It's going to be a little bit crazy. This up here, you're going to have to do, let's see, we're in unit 10. So yes, you can use P over Q and factor that one. You're going to wind up with a slant and a hole and a vertical. The vertical is pretty obvious because X can't equal 0. And since you don't have an X up here, you know that's going to be a vertical asymptote. And then when you graph it, the easiest way to do something like this is graph it and kind of take a look at it and see what it looks like. All right. Stop by and see me after school, before school. Send me a text if we're still distance learning. Let me know, and I will walk through this one with you. But right now, it's just getting a little bit hard to use the mouse and draw as a pen. I want to move on, and the video is getting long. I want to go on to Unit 10, Objective 2, solving problems involving direct, inverse, and joint variation. Direct variation, y equals kx. Inverse variation, y equals k divided by x. Joint variation, that's where you have y equals k z x. Okay, where z and x are both variables. Okay, and then you can also have combined where you have something where it's both joint and direct. So this first one, when the temperature stays the same, the volume of a gas is inversely proportional. Right there, it tells you inversely proportional, that's inverse variation, to the pressure of the gas. So volume equals K over the pressure. Then they tell you that at 81, gas pressure of 14. So you can use that information, 81 is equal to K over 14, multiply both sides by 14 to get the value of K. Then find the new pressure if the volume is decreased to 27. So you plug the K in, you take the new pressure, or the new volume, and you multiply both sides. So you're going to wind up with 27P is equal to 1134. Divide both sides by 27, and you get 42 pounds per square inch. Probably the hardest thing here is deciding whether it's direct or whether it's inverse. Okay? Now, a person's hair length varies proportionally with the number of weeks it has been growing. Varies proportionately would indicate direct variation. If Bob shaved his head bald and his hair was at 0.24 inches long after 8 weeks, how long would it be after an additional 8 weeks? Well, 0.24, after 8 weeks, you get your K. You have to find your K first. Then you're going to plug your K in. You want to know how long it's going to be after an additional 8 weeks. Well, 8 plus 8, right? 8 plus 8 is equal to 16, and so you get 48 inches. Number 3, the time needed to paint a fence varies directly with the length of the fence and inversely with the number of painters. Time varies directly with the length and inversely with the painters. So this is a combined variation. You take what you know. It takes 5 hours, boom, to paint 200 feet using 3 painters. Multiply both sides by 3 and divide both sides by 200, and you get 0.075. You're going to take the value of K and plug it in. You now know that you have 5 painters. Okay, there's the 5. Painting 500 feet, well, that's going to take 7.5 hours. You simply multiply 0.075 times 500. Finally, we have the volume of a pyramid. It varies jointly as its height and the area of its base. Okay, so we have volume varies jointly, means you've got 2 things, as the height and the area of its base. So you're given information, the 12 and the 23, 12 feet high, 23 is the area, and it's equal to 92. Multiply these 2 together, you get 276, divide both sides by 276, K is equal to 1/3. You plug the 1/3 in, and this should look familiar from geometry. Volume is equal to 1/3 H times A, where A is the area of the base. And you get 1/3 times 17 times 27, 153. That's the volume of the new pyramid. All right, that's all there is to it. Good luck. I know you can do it. It's not hard. You just have to remember the steps. Just got to remember the steps. Take it one piece at a time. Answer as many questions as you can when you're taking the test. All right? Have a great day.